Hello, everybody. So here's what we're going to do today. Now, for fourth period, I saw you today. For eighth period, I wasn't able to be there. I apologize. I had a meeting I had to go to. But what we're going to do, all you need to do today is these 6 problems on this worksheet. So I've posted this worksheet on the assignment sheet, and I'm going to go through all 6 with you. If you need the help, go through the help. I'll also post an answer key if you just want to check your work. Okay. But real quick, what we're going to do is I'm going to do a quick review. I'm going to give you a chart. With the formulas we've done so far. Before we really go on to sums, I think it's worthwhile to go and kind of review what we've done so far. So we've got a couple different types of sequences. We've got arithmetic sequences, and we've got geometric sequences. Okay, arithmetic sequences have a common difference. D is your common difference, which means your terms are going up or going down by the same amount each time. Geometric have a common ratio, we'll call it R. Okay, and that means to find the next term, you're multiplying by the same number each time, and that thing you multiply is the common ratio. Okay, we're going to go through the explicit formulas, and we're also going to go through the recursive formulas. Okay. So even if this is straightforward, you understand it is really easy to get confused between the different formulas. So this one, the arithmetic formula, is to find any term a sub n. You take the first term, and you're going to add your common difference n minus 1 times. So it's a sub n equals a sub 1 plus d times n minus 1. The geometric formula is kind of similar. You take, to find any term, you're going to start with the first term. But remember, you're not adding something. You're not adding a common difference. You're multiplying by something. So you're going to multiply by your common ratio, not n times, but n minus 1 times. When you multiply by r times r times r times r, if you multiply by r 4 times, that'd be times r to the 4th. Okay? And if you multiply the first term by r 4 times, you actually get to the 5th term. So you've only multiplied by r 4 times. So these are your formulas. I know you're familiar with these. Okay, now let's look at the recursive formulas. The recursive formulas, as long as you understand the notation, it's actually a little bit easier. So this says that a sub n, to find any term, you're going to take the previous term, which we call a sub n minus 1. That is the term immediately before a sub n. You already know this. It's arithmetic, so you're just adding your common difference to the previous term. So you're going to take any term, you look at the previous term, and you add your common difference. That's all you do. The recursive formula for geometric, a sub n. You take the previous term, a sub n minus 1. Again, that's the term before a sub n. What are you going to do? You're going to multiply by r. Okay, so these are sequences like, and I'll give you a couple examples down here. This one, let's say we start with 5, 7, 9, 11, dot, dot, dot. Okay, your common difference is 2 because you add 2, you add 2, you add 2. We call it a difference because to find it, you just subtract. You take a term and subtract the previous term. You take a term and subtract the previous term. If you keep getting the same thing, that's your common difference. Okay, so to find any term, let's say we want to find this term, we can look at, let's use this formula, look at the term before it, so this term. For instance, that's the first, second, third, fourth, fifth term. To find the 5th term, we look at the 4th term, and we're going to add the common difference, add 2 to it. Okay. Now let's look at a geometric sequence. So let's say we start with something like, I'll give you something else a little more interesting, 16. And then the next one is 8. Then the next one is 4. And then the next one is 2. And the next one is 1. Okay. Notice I'm multiplying by 1/2. If you didn't see that right off the bat, you could find your common ratio. Your common ratio means you take any term, divide by the previous term. 8 over 16, which reduces to 1/2. 4 over 8, take a term, divide by the previous term. Reduces to 1/2. Okay, if that keeps happening and you get the same common ratio, you know it's geometric. Now let's look, how do we find the next term? Well, to find any term, you look at the previous term, the term right before it, you multiply by your common ratio. So we're going to multiply by 1/2, which means 1 times 1/2 is 1/2. Find the next one, 1/2 times 1/2, 1/4, and so on. So this is a reference sheet. I will post this also. Okay, it's a 1/2. Okay, and now we'll go through the 6 problems on your homework. So we'll try to get through these quickly, and hopefully you understand these and you get done quickly today. Okay, so determine if the sequence is arithmetic. Okay, well, we know it's arithmetic if it has a common difference, if we're adding the same amount each time. So let's check. Let's subtract our terms. Say, from here to here, are we adding the same amount as we do from here to here or from here to here? I'm going to start with these two. Let's find the difference between these two. Okay, the difference is 48 minus 28. 48 minus 28 gives you 20. Okay, let's see if that's the same difference if we chose these two terms that are next to each other. 28 minus 8. Well, look at, what do you know? That's 20 also. Then let's look at the first two. 8 minus the difference between 8 and negative 12. 8 minus negative 12. When you subtract 12, you add a positive. 8 plus 12 is 20. Our differences are all the same. Our common difference is 20. Okay. If it is, find the common difference. We already did that. Find the 52nd term, the explicit formula, and the recursive formula. Okay, so let's find our explicit formula. It's arithmetic. We're going to use this formula, and then for recursive, we're going to use this formula. Now, one thing about a recursive formula, you must also state your first term. Okay, state the first term, a sub 1. This one also, state first term, a sub 1. And I'm going to talk about why that is, okay, when we get to that part. Okay, so but the explicit formula is a sub n equals a sub 1 plus d times n minus 1. So our formula is a sub n equals a sub 1. That just means your first term, so negative 12, plus your common difference. Common difference is 20. We plug that in for d, and then n minus 1. Okay, you're pretty much done there. But what we can do, we can simplify. Sometimes you'll see, like on a multiple choice test, you have to pick an answer, and this is not one of your choices. So we're going to multiply, distribute this, and simplify. So 20 times n plus 20n. 20 times negative 1 is minus 20. Combine your like terms. A sub n equals negative 12 minus 20 gives you negative 32 plus 20n. There's our explicit formula. Okay. If you want to find the 52nd term, a sub 52 equals negative 32 plus 20 times n. You're finding the 52nd term, so n is 52. Okay. And what you get there, 52nd term, when you add that together, you get 1008. I'll say equals a sub 52. Okay, and the only thing we have to do is find the recursive formula. Okay, running out of space, let's do it over here. The recursive formula is a sub n equals your previous term, a sub n minus 1. Let's check our formula for an arithmetic. Remember, we look at the previous term, and what do? You just add your common difference. So a sub n minus 1 plus 20. That's your recursive. Okay? And we're kind of done, but the problem is you have to give it a starting point. So you have to also state a first term. A sub 1 equals negative 12. Okay, let's go on to the next one. Determine if the sequence is geometric. Well, how do you know if it's geometric? It's geometric if it has a common ratio. And if it has a common ratio, you're just going to plug that common ratio in here, and you've got your formula. Plug in the first term, and that's it. Okay. So if it is, find the common ratio, find the 8th term, find the explicit formula, find the recursive formula, and the 3 terms in the sequence after the last one given. Okay. So let's first determine if it's geometric. Let's find our common ratio. Let's find the ratio of the first 2 terms. 12 divided by 4. That reduces to 3, okay? Let's see if now that we looked at the first two terms, let's look at the second and the third term. You look at any consecutive terms. We have to do a term divided by the previous term. When you make that fraction, that's your ratio. So 36 over 12, and that also gives you 3. Now let's try just for fun. Let's try the third one. R equals 108 divided by 36. That also equals 3. Notice our R equals the same thing, so our common ratio is 3. Okay. Now let's find our explicit formula. The formula for a geometric sequences is a sub n equals a sub 1 times r to the n minus 1. Okay. So a sub n equals a sub 1 times r to the n minus 1. Okay, let's plug in what we have to plug in. You want to leave n in your answer, but we have to replace a sub 1 and r. A sub 1, that's your first term, 4. The common ratio is 3 to the n minus 1. Right there is your explicit formula. Let's find the eighth term, a sub 8. Notice we're replacing the n with an 8. So over here, we replace the n with an 8. Equals 4 times 3 to the 8 minus 1. Let's simplify. 4 times 3 to the 7th. Okay. Plugging that in your calculator, you're going to get a sub 8 equals 8748. Okay, so we find our common ratio. We found that it is geometric. Say yes. Up here, let's say yes. We found it was because it had a common difference. This one has a common ratio, so it's geometric. And the last thing it wants us to do is find the recursive formula. So the recursive formula says a sub n means what we do is we look at the previous term, the term right before it, and we multiply by our common ratio. Okay, so a sub n equals a sub n minus 1 times r. So a sub n equals a sub n minus 1. You're going to leave that in your formula, and we're multiplying that times your common ratio, which was 3. Okay, but we have to give it a starting point, so our first term is 4. And there's your recursive formula. We need these two parts right here. Okay. Then it says find the next 3 terms. So after 108, 4, 12, 36, 108. And then the next 3 terms. All we do to find the next 3 terms, we keep multiplying by our common ratio. We're going to multiply by 3. 108 times 3 gives you 324. Find the next one. Times 3, we get 972. Find the next one. Times 3, and you get 2916. All right. Okay, let's go down. 2 down, and those are probably the 2 longest ones. Okay, so let's go to number 6. Find the missing term or terms in each arithmetic sequence. The nice thing is they told us this is arithmetic. If we think about what happens to find the next term, okay, if it's arithmetic, we're adding the same amount each time. So to get from this term, let's call this the first term. Call that a sub 1. Second term, third term, fourth term. A sub 4. Okay. I think the easiest way to do this is just to kind of figure it out. We know to get to the second term, we're going to add our common difference. They tell us it's arithmetic, so we've got a common difference. Now, we don't know the common difference, so we got to figure that out. But to get to the second term, we've added d. To get from the second term to the third term, we're going to add d again. And to get the third term to the fourth term, we're going to add d again. Okay? So let's make an equation. To get from 6, the first term, to 306, what do we have to do? What we've done, we've added d, and we've added d, and we've added d. So plus d, plus d, plus d, and then we got to 306. Okay? These we could combine. d plus d plus d. That's 6 plus 3d equals 306. Okay. To get from here to here, we had to add d 3 times. So we added 3d. Let's solve this equation. Minus 6 minus 6. Those cancel. We've got 3d equals 300. Divide by 3, divide by 3. Well, d equals 100. Okay, now that we know the common difference and we know it's arithmetic and we're adding 100 each time. So 6 plus 100 gives us 106. 106 plus 100 gives us 206. 206 plus 100 gives us 306. So our missing terms are 106 and 206. You could just write them in there. Okay. Now the same idea for the next one, except it's geometric. We've got 3, we've got a term, and then 192. Let's call this our first term, a sub 1. Let's call this that would be our second term, our third term, our fourth term. Fourth term, we just call a sub 4. Now to get from the first term to the second term, what do? We're not adding something, it's not arithmetic, we're multiplying by something. And we know we're multiplying by the same number each time. So multiply times r. To get from here to here, we multiply by r again. To get from here to here, we multiply by r again. Okay? So to get from 3 to 192, we have to start with the 3. We multiply by r times r, multiply by r again times another r, multiply by r a third time times another r, and only after we multiply by r 3 times is when we get to 192. Okay, r times r times r is r cubed. 3r cubed equals 192. Solve this equation. Divide by 3, divide by 3. 3's cancel, and we get r cubed equals, what does that give you? 64. Okay. So we have to take the cube root of both sides. You could do that on your calculator, or maybe you'll remember that the cube root of 64 is 4. Okay. We know that because 4 times 4 times 4 gives you 64. You can just double check that if you want to double check that. But our common ratio is 4, which means, let's look at our terms. We've got 3 blank blank 192. So you get from 3 to the second term. This is a little small to write it in, so I'm going to write it over here. 3, we have to multiply by 4. So we know our common ratio now is 4. 3 times 4 gives us 12. 12 times 4 gives us 48. And 48 times 4 gets us to 192. The nice thing about these problems is you can check your work and make sure you got it right. Okay? You can check it out, make sure that checks out. If you multiply by 4, multiply by 4, multiply by 4 again, and you didn't get 192, you'd be like, oops, I made a mistake. I might go figure that out. Okay? Let's go to the last page, last 2 problems. Determine if the sequence is arithmetic. If it is, find the common difference. Oh, did we? No, this is similar instructions, but we haven't done this one yet. Okay, is it arithmetic? Let's find our common difference. The difference between the first 2 terms, 57 minus 37, is 20. Difference between these 2 terms looks like it's 20 again. These 2 terms looks like it's 20 again. Our common difference is 20, which means, is it arithmetic? Yes. Let's find, we found the common difference. Let's find the 52nd term. Okay. Find the explicit formula. For an arithmetic sequence, your explicit formula is a sub n equals a sub 1. You're adding your common difference, n minus 1 times. So a sub 1 plus d times n minus 1. So a sub n equals your first term, 37. A sub 1 means your first term, plus your common difference, which is 20 times n minus 1. And we can simplify that. 37 plus 20n minus 20. So a sub n equals, add your like terms, 37 minus 20 is 17 plus 20n. There's your explicit formula. Notice here you don't have to come up with your recursive formula. Okay. Find the 52nd term. So all we do is we plug in 52 into the equation. A sub 52 equals 17 plus 20 times n, 20 times 52. Okay. And we get a sub 52 equals, when you plug this in your calculator, you should get 1057. And the last problem, and we're almost done. And then you are free for the day. Okay, determine if this, well, make sure you submit this under the homework. Okay, determine the sequence is geometric. So, and if it is, find the explicit formula and the recursive formula. So if it's geometric, we're looking for a common ratio. Let's find the ratio of the first two terms. 16 over negative 4. Okay, 16 over 4 is 4. It's negative. Let's do the next two terms. Negative 64 over 16. Plug that in your calculator if you want. You get negative 4 again. Let's find the ratio of the last two terms. 256 over negative 64. Negative 4 again. We get the same ratio. If we get the same ratio each time, then we know there's a common ratio. Our common ratio is negative 4. Okay? Which means, yes, it is geometric because there's a common ratio. Let's find the explicit formula. So a sub n equals a sub 1 times r to the n minus 1. Plug in your first term, which is negative 4. Plug in your common ratio. Okay, interesting, which is also negative 4. Okay, there's your formula. We don't have to find the 52nd term. We just have to find the recursive formula. Remember your recursive formula. All you do for a recursive formula is you have to know that to find a term, you look at the previous term and multiply by r. Okay, so a sub n equals a sub n minus 1 times r. Let's plug that in. A sub n minus 1, you're going to leave that in the formula. You're multiplying by r times negative 4. And don't forget, you need to give it a starting point when you have a recursive formula. So let's say the first term is negative 4. So those two parts. And that's it. So just take pictures of your work, submit them into Schoology, and have a wonderful day. Thank you all for watching.